Thank you for joining our telecom. We will now hand it over to NASA JPL.
Hello, welcome to our teleconference. We are doing some sound checks right now, and after our sound check, we will go live and start the briefing. Thank you. To start, I'd like to get the names of our presenters.
Robert Hogg.
Anais Zarikian.
Katie Stack-Morgan.
Thank you, and stand by. We will go live shortly. Welcome to today's teleconference. Mission team members from NASA's Jet Propulsion Laboratory in Southern California will discuss some of the first accomplishments of the rover to date. I'm your host, Raquel Villanueva. Joining us on this teleconference is Robert Hogg, Perseverance Deputy Mission Manager, Anais Zarikian, Perseverance Mobility Testbed Engineer, and Katie Stack-Morgan, Perseverance Deputy Project Scientist. For anyone listening who would like to submit a question, you can do so by using the Countdown to Mars hashtag. Our phone lines are now open to the media. You can ask a question by pressing *1 to enter the queue. To access the images that we will be seeing during the event, visit nasa.gov/perseverance-first. To set the stage, NASA's Mars 2020 Perseverance rover touched down at Jezero Crater on February 18th, and the team has been very busy since. I'll hand it over to Robert to talk about what the team has been up to.
Thanks a lot, Raquel. Well, everything is going very well on our latest mission to Mars here. Perseverance has been doing an exceptional job during her first 2 weeks on the red planet. One of the great things about the beginning days of these missions is all the things that happen for the very first time every day. For example, the first image that came down after we landed, the rover's first radio report back to Earth via our orbiters, the first color panorama of our landing site, all the first instrument checks after landing, and the first time we get to see various major parts of the system working as they should. So on that note, I'm happy to report that yesterday afternoon we carried out our very first drive on Mars. Go ahead and show that first picture, please. Here we're looking out the front of the rover, and you can see our first tracks on Mars, and this was just so amazing to see last night, and we're really happy about this. Anais is going to talk to this first drive in detail shortly, so we'll come back to this. So I'll describe another recent first, which was our robotic arm checkout, which we carried out on Sol 12. Go ahead and show that next graphic, the simulation of the arm moving. So this is with our 5-degree freedom, 7-foot-long robotic arm with its very complex turret assembly at the end. The turret weighs 45 kilograms, or close to 100 pounds, so this thing is massive. What you're seeing in this simulation is it's actually a representation of the telemetry we got back of what the arm did on Mars, of all the different motions of the arm. We call this the no-load checkout. It unstows and places the whole arm in a vertical orientation, and then it does a test wiggle of each joint, and then it restows. Next image. So here you're seeing the actual images from the rover that we got back of this activity, which was super cool. I should mention the turret has two of our very important science instruments, Sherlock and Pixel, and it also has an engineering camera, Watson. So, yeah, Sherlock and Watson will be doing up-close sleuthing for us on Mars here. And, of course, the turret has the very important abrader and corer for drilling and taking the samples that we hope to return to Earth. And finally, it has the GDRT. We call it the gas dust removal tool for blowing surfaces clean. This robotic arm is also used for engineering imaging. For example, being able to see under the rover where the helicopter is and taking our now famous rover selfies. So great to see it unstowed here and put through its paces for the first time. Another important first, or area of first, is all the science instrument deployments, checkouts, and calibrations that we've been doing over the last 5 days. One of these that was really fun to see was the META instrument, our weather station from our partners in Spain. Please show this next picture, R4. So in Sol 12, we deployed the META wind sensors, which are housed on the mast. And you can see them in testing on Earth on the left. And then on the right is a little animated GIF of on Mars, showing each wind sensor successfully deploying. So that was great to see. There's one more important milestone I want to describe that doesn't involve any great images, but it's vital, and that is our flight software update, the software that runs the rover. After landing, we spent a few sols doing a complete upgrade to our surface software, which has been in development and testing for many, many years. So this is the software that really releases all the capabilities that Perseverance has available for our surface mission. It's about 16 megabytes, so pretty small, but when operating, it has 140 tasks all running on the rover's computer at the same time. And when we did this update, we had to be very careful not to have any major problems because, you know, there's no helpline to call or any way that we can run over to the rover and press the big reset button. So we were very careful, and getting it done was a big relief for the team. And so the end result is kind of like getting an update to your electric car software. One day your car knows how to do autonomous driving, detecting obstacles and navigating by itself amongst many, many other bells and whistles that we have in store. All right, so I'll now hand it over to Anais, and she can tell you all about our first drive.
Thanks, Robert. So before I get into the first drive, I wanted to give a little overview of our mobility system. So if we go to the first graphic, A1, so you'll see our rover during its first drive on Earth. We are a six-wheel drive, so with one motor for each of the six wheels that move us forward and backward. And our four-corner wheels are able to steer. So that's 10 actuators total. But with only 8 motor control cards, we can't drive and steer at the same time. So if we ever want to turn, we have to steer the four-corner wheels in place first and then drive a longer path. So we can turn in place or drive along fixed curvature arcs, and all at a top speed of 0.01 miles per hour. So not very fast. And you'll kind of see those arcs and those tracks when we get into a later picture of the first drive. The wheels are all attached to a rocker bogie suspension system, which has heritage all the way back to Sojourner. And so even though Perseverance is obviously a much larger rover, we're still able to use it. And with our suspension design, we can technically drive over rocks that are about 1 wheel diameter in height while still keeping the rover chassis leveled. So, you know, I mentioned our suspension design has heritage back to Sojourner. Even parts of our software are built upon code that we've used in previous rovers. So the mobility system that you see today is really built over decades and several missions, with each one making improvements over its predecessor. So some new things that we have on Perseverance are redesigned wheels. They're slightly narrower, they're thicker with a larger diameter, which gives us some better traction. And we have a new grouser design. The grousers are the treads, that tread pattern you see on the wheel, and it makes us less prone to tears in the wheels when we drive over sharp rocks. Another notable new addition to our system is the VCE, which is our vision compute element. If you remember from EDL, we had the VCE for terrain relative navigation, but now that we're on the surface, we've repurposed it entirely for the surface mission to process imagery for mobility and help us with our autonomous navigation. So that same electronics box, because we can't physically change anything on it now that we're on Mars, now has a brand new software installed on it, and it's ready to go for driving thanks to our incredible VCE team. So that was just one of the things that we did in preparation for our first drive. If we go to our second graphic, A2, we also did a sphere actuator checkout. So I mentioned each of our 4 corner wheels are able to turn. We commanded each of those 4 wheels through 30-degree range of motion while monitoring motor performance and suspension angles. And it went really well, in certain cases better than we expected. We saw some performance, but in some cases was better than we've seen on Earth driving in the Mars yard. And whether that's from the underlying terrain or, the Mars gravity, we're not entirely sure, but it worked beautifully. And we were so excited to move on to the first drive. So if we go to A3, you'll see what our first drive actually did yesterday. So our plan, which executed perfectly, was to first drive 4 meters forward, that's about 13 feet, make a 150-degree turn to the left, counterclockwise, and then back up about 2.5 meters, about 8 feet. And then during that drive, we took a pause to image the touchdown contact patch on the tires, so where the tires made contact, or the wheels, I should say, where the wheels made contact with the ground when we landed. And also throughout the drive, we took some images from the nav cams and processed them on our VCE to kind of prove that software pipeline that feeds images into the VCE for perception and image processing. So our first drive went incredibly well. If we go to A4, you can see the wheel tracks that we left on Mars. I don't think I've ever been happier to see wheel tracks, and I've seen a lot of them. And this is just a huge milestone for the mission and the mobility team. Like, we've driven on Earth, but driving on Mars is really the ultimate goal. And just so many people I can't even count have worked towards this very moment for years. Whether they worked on designing and building the actuators, the newly redesigned wheels, the motor control system, writing this incredibly intricate mobility flight software, or spending days and nights in the test bed in the Mars yard, testing, debugging, and retesting the mobility system to make sure everything works together. Like, this is really what we've been working towards, and it's just amazing to see. I don't think the team could have been happier. So, looking ahead, we're going to do some longer drives. This is really just the beginning. Now that we've showed that we're able to drive and we can do this, our mobility system is capable of doing so much more. We still drive at 0.01 miles per hour, same as Curiosity, but thanks to our improvements on our AutoNav software, our enhanced navigation software, and our new cameras, we can really drive 5 times faster than Curiosity, and we're capable of averaging about 200 meters per stall. And that's also partially due to the VCE, which offloads the burden of image processing from the rover's main computer. We're able to think while driving. So in other words, Perseverance can walk and chew gum at the same time, is a phrase we kind of like to use. And so we're able to take a stereo pair of images, process those images on the VCE, identify hazards in the terrain, and choose a safe path forward, all while the wheels are still turning and moving forward. And so this means we can drive longer in the same amount of time, and we can have less time planning drives and driving on the surface, which means more time to do science, which is why we're there in the first place. And speaking of science, I will hand it over to Katie to talk about what the science team is so excited to do with all the extra time they're going to have.
Thanks so much, Anais. If we could please bring up K1. As the Perseverance team celebrates the rover's first successful drive on the surface of Mars, I am honored and excited to announce that Perseverance's landing site is now called Octavia E. Butler Landing. If you could bring up K2, please. The Perseverance science team has chosen to name the touchdown site for Octavia E. Butler, a visionary author and Pasadena, California native who is the first African-American woman to win both the Hugo Award and Nebula Prize for Science Fiction, and the first science fiction writer to be awarded a MacArthur Fellowship. Butler's pioneering works explored themes of race, gender, equality, and humanity, centering on the experiences of Black women at a time when such voices were largely absent from science fiction. Butler's protagonists embodied determination and inventiveness, making her a perfect fit for the Perseverance rover mission and its theme of overcoming challenges. Butler inspired and influenced the planetary science community and many beyond, including those typically underrepresented in STEM fields. And the fact that her works are as relevant today, if not more so, than when they were originally written and published is a testament to her vision, genius, and timelessness. Naming Perseverance's landing site in honor of Octavia E. Butler honors a notable science fiction writer, a theme also used by the Mars Science Laboratory team, who named the Curiosity rover's landing site in honor of science fiction writer Ray Bradbury in 2012. We chose on this mission to continue this theme in appreciation of the role that science fiction writers have played in inspiring so many of us to become the engineers, scientists, and explorers who turn science fiction into reality for the next generation. While Perseverance has been positioned at Octavia E. Butler Landing, the science team has been really busy. The META instrument, the rover's weather station, has already begun collecting and returning data to Earth. And 2 weeks into the mission, we've received about 7,000 images from the rover's cameras, including our first views of some of the geologic targets of exploration that brought the rover to Jezero. If we could please bring up K3. This image is from the Mastcam Z camera located on the rover's mast. It shows a flat, light-toned rock on the right side of the image on which we targeted the very first observation from SuperCam, one of the rover's instruments for analyzing the composition of rocks at the surface. Results from this first observation will be presented at a special SuperCam briefing next Wednesday. But on the left side of the image, rocks characterized by holes partially filled with dark sands contrast with the lighter tone, smoother texture of the rock on the right. The image colors that you can see here portray an estimate of the natural color of each of the scenes and are approximately what this scene would look like if you viewed it with your own eyes here on Earth. If we could please bring up K4. And what we can see in this image from the first high-resolution panorama from Mastcam Z are distant deposits of the Jezero Delta in the background. The rocks in the foreground may be similar to those in and around the rover's landing site, but I'd like to call attention to the rocks in the mound in the background. This is about 1.5 miles away from the rover. And these rocks look notably different in that you can actually resolve layering within the rocks you see in this outcrop. These resistant layered rocks were likely deposited by rivers flowing into the ancient Lake Jezero, and scientists on the team are hard at work trying to understand the significance and origin of rocks like this that we're seeing on the ground at the landing site for the very first time. But before we can think about exploring the Jezero Delta, we have to figure out how to get the rover there. The science team is working with engineers to determine the best path for the rover to drive to the Delta. So if we could bring up K5, please. This is a base map made of orbiter images from the Mars Reconnaissance Orbiter HiRISE camera showing possible traverse paths that the science team is considering for exploring Jezero. From the landing site, which is the white dot there, we're considering 2 options to get to the Delta, a clockwise path and a counterclockwise traverse that you can see here in blue and purple. We're working with engineers now to determine which path is most efficient and safest and most scientifically interesting for the rover to explore, and then we'll arrive there at the front of the Delta. From there, we'll go and explore the Delta, and eventually winding up at the mouth of the river that once entered Jezero, where we will likely deposit our very first sample depot. But to return to near-term milestones, the rover team has just planned a drive early this morning incorporating RIMFAX, the rover's ground-penetrating radar system that we can use to see into the subsurface. This first data set will add to our understanding of the geologic context of Octavia E. Butler Landing and will set us on our path to begin exploration of Jezero Crater. So with that, I'll hand things back to you, Raquel.
Thank you, Katie, and thanks to all our speakers. We are now ready to take media questions. Remember to press *1 to get put in the queue, and please direct your questions to one of our guests. We're also taking questions through the Countdown to Mars hashtag. We'll start with Marcia Dunn from the Associated Press.
Yes, hi. Can you hear me?
Yes, we can hear you.
Yes, I have a question for Ms. Serafian. I'd like to know, how, I know you said that the rover drove 40 meters, then did a little spin. In total, how much distance has it traveled in this first test drive, and over what period of time? What's the odometer say, and how long did it take to get there, and when will it be driving again? Thank you.
Sure, yeah. I'm not sure of the total odometer. I mean, to date, this is all we've driven, so 13 feet plus 8 feet. And so, oh, sorry, I'm getting.
Marcia, could you try muting yourself? I'm trying to see if there's an issue with.
Yes, that might have been me. My apologies. I'll
no problem.
Now,
let's try that again. Okay, we'll have you mute, and Anais, start in like 5 seconds.
Okay, so in total to do this, it took us about 33 minutes to execute the drive. It wasn't very long, and we drove about 6.5 meters total. When we plan on driving next, that would be today. We have a slightly longer drive planned. I'm not exactly sure on the drive path because our rover planners have spec'd that out entirely. But yeah, we're driving today and hopefully tomorrow if all goes well.
All right, thanks, Anais. And up next is Bill Harwood from CBS News. And Bill, after you ask your question, could you please mute your mic? We'll try it out that way. Thank you.
Absolutely, I'll be happy to do that. A question for Katie. I was thinking back on Curiosity, and it seemed like the rover would get to Mount Sharp relatively quickly, and of course it took months and months and months because of all the neat things you guys found to look at along the way. Is there even a nebulous timeline that says, regardless of which path you choose, how long it might take Perseverance to get to the Delta? And I'm asking that especially because of the improvements you guys have put in it that let you go up to 200, meters per day. Just trying to get a sense of what the time is here. Thanks.
Yeah, that's a great question, and it's something we're very eager to know as well. And actually, we're right in the middle of conversations with what the strategic rover planners who are responsible for helping us figure out how long it takes to get places and where we're going. And so they are just providing us the first estimate for getting to the Delta. And so we are learning that information real time ourselves as well. So I don't have an exact number to give you, but we are eagerly engaging in those conversations with the strategic RPs right now.
Thank you, Katie. And up next we have Chelsea Scott from space.com.
Awesome. Thank you so much. Can you hear me?
Yes, we can hear you. Thank you.
Great. So my question is for Katie. I'm curious that now that Perseverance has taken its first steps and, over the last 2 weeks, so many images have been sent back, I'm curious, have mission scientists been able to determine some of the types of rocks and surface material that are being seen in Jezero Crater and how that might compare with what you expected to see?
Yes, thank you for that. So we have acquired abundant images now of our landing area, and so we are seeing all kinds of textures in the rocks that are around Perseverance's landing site. But we are only just getting our other instruments checked out, and so those other instruments are really important for us to put together a model for how these rocks formed and what their significance might be. And I think next Wednesday we'll hear results from the SuperCam instrument, which I think is really the next step in helping us determine what these rocks are and what they might be. We landed in a very interesting area where we are trying to figure out the origin of these rocks. Are they volcanic or are they sedimentary? And this is what the team has been thinking of. But it's hard to do that with images alone. And especially with kind of far distant images. And so we do a lot of speculation on the line first, with the science team, but as we continue to acquire data sets and check out our instruments, we're going to learn more about these rocks and get those close-up views of the textures and composition that are so important in helping us determine exactly what these rocks are that we're looking at.
Thank you, Katie. Up next, we have a social media question. Bob on Facebook asks, what training do you have to drive the rover? Anais, is that for you?
Sure, I can answer that question. My job is to look at data that's downlinked from the rover. It's actually a completely different set of people that plan these drives. We call them rover planners. And I believe the training, is something like, a few months of using like really specialized software and learning how to plan these drives. And it's not actually something that I've done. But as far as, my background for being a mobility test engineer and getting into the field, I majored in mechanical engineering at UCLA, and I was always interested in robotics and, systems that moved and interacted with electronics and software. And so that's how I got into what I'm doing. But I don't actually plan the drives.
Great, thank you, Anais. Up next, we have Steve Gorman from Reuters.
Yeah, hi. Let me turn my... So I had a couple questions. Have you guys made any O2 yet from the CO2 in the atmosphere? I don't know if you've done any of that. And also, has anything gone wrong? Have there been any unexpected glitches or sort of problems you've had to overcome in terms of you've come across while checking out the equipment? And also, what are we still talking about the same time frame that you had discussed earlier about as far as when you might get to the trying to fly the helicopter?
Robert, do you want to take that?
Sure, I can take some of those. So no, we haven't run the MOXIE experiment yet, and so we've checked out the instrument, but we haven't generated any O2 to my knowledge, and Katie can correct me on that if that's off. And we haven't had any hardware issues. No, everything has been working that we've been checking out, and so it's actually been amazingly smooth in that respect. I'm going to knock on wood here, and we've had minor little things on process and questions come up, but it's all just minor stuff. And Perseverance is everything that we've looked at and tried has worked beautifully, and is really happy with the hardware on the surface. And then on the helicopter tech demo, we're still figuring out the possible flight zones, and we're taking NavCam images, stereo images, to be able to analyze the terrain. And also the team's been looking at orbital images, looking at possible flight zones. And long story short, we're still aiming for getting that done in the spring here before we're into summer.
Thank you. Thanks very much.
Thanks, Robert. Up next on the phone lines, we have Craig Senior from KNX News Radio.
Thank you. I just wanted to know, when you talked about the distance that it's traveled, the way I calculated it was just over 7 yards. I want to make sure that's correct. I also wanted to know, and apologies if you said it already, but how long did it take to travel that distance yesterday?
Yeah, so 6.5 meters total. I don't know the conversion off the top of my head, but I think that's about 21 feet that we've driven, and it took us about half to complete that drive.
Thank you.
Thanks. And after that, we have John Wentz from Inverse.
Hi. I was just wondering if there is a timeline so far for when we might see some of the first tests of the helicopter that was brought aboard.
Robert,
yeah,
would you
this
like
is
to
Robert.
that one?
Sure. So yes, similarly, by first test, maybe you mean flights. We are the first thing that has to happen is we need to deploy to the surface of Mars, and so we're still analyzing various areas to determine the best place to do that and the right place to do its flights, its flight zone. So the first test will happen after the deployment happens. And I won't get into all the details on that. We'll be covering that in a couple weeks. But again, we're not on a specific path at this time because we still need to figure out where we're going to do it and get through some other checkouts in the sampling caching system area. So we hope to get the whole helicopter thing going before spring is over. And so we'll be doing those first low spin tests and checkouts and stuff before the actual flights, definitely before the summer.
And to go off what Robert said in the next couple weeks, we will have a briefing detailing the latest test schedule and milestones, so stay tuned for that as well. And then we now have a social media question to take. Bella in London, she's 9 years old. She asks, how is Perseverance not freezing on Mars? Katie, would you like to take that?
Yeah, although actually I might have Robert help me out with this too, because what we've learned from the META instrument is that it is indeed very cold on Mars, and rovers, need to be warmed up to operate, just like we need to stretch and flex our own muscles before we go for a run. And so what the rover does is it uses heaters. It has heaters that are part of the rover that it uses to heat up its various mechanisms. And so before we do activities like driving or using the instruments or using the rover's arm, the rover warms up. It heats itself up so that its mechanisms work the way that we expect them to work.
That's great, Katie. Yeah, great question. And we build Perseverance out of materials that can handle the cold temperatures on Mars. And after we put all these different things together, we put the whole rover in a big spacecraft test chamber, and we take it down to the different temperatures that it's going to experience overnight and during the day. And so we get as cold as minus 120 Celsius when we were doing that test with the rover, and that's down at about 180 Fahrenheit, just to make sure that all the aluminum pieces and all the electronics boards and everything are going to do just fine. And as Katie mentioned, a big part of that is making sure our whole heating system is working correctly to keep the sensitive parts warm enough so that we can have a mission for several years on Mars. Thanks for the great question.
Yes, thanks for writing in, Bella. Up next, we do have Irene Klotz from Aviation Week.
Thanks very much. I have two questions. First for Katie. Is the decision about whether to go to the left or the right to the Delta at all related to where the helipad is selected, or are those completely separate operations? And for Robert, you mentioned the sampling caching system still has a checkout ahead. What other instruments still have to go through that? Thanks.
Yeah, I can take that first part of the question. Thanks for the question. So there are a couple different factors that I think are likely to play into our decision of whether to take the clockwise or counterclockwise route. One is the type of terrain and how quickly and efficiently the rover planners think we can traverse that terrain. We're very excited to get to the Delta, and we want to begin that exploration, so we are looking to get there efficiently. But also along the way, we're interested in doing science as we go, and so we're also thinking about interesting science targets along the way. The counterclockwise route to the north is very smooth, relatively speaking, but perhaps less interesting science targets along that way, whereas the southern route takes us past some of these remnant deposits of the Delta, which might give us an opportunity to preview the delta before actually arriving there. So we're very interested in that clockwise route. And the decision to go north or south is largely decoupled from the helicopter. And there are a number of flight zones that the team is considering. But once the helicopter has finished its mission, that's when we'll decide really whether to take the clockwise or counterclockwise route.
On the sampling caching system and instrument checkouts, we're actually a good deal along on all the instrument checkouts. We're just finishing up the basic checkouts, and then there'll be more use case specific things that we'll be doing. And one of those, for example, is the Pixel and Sherlock instruments at the end of the arm being placed up close to the Martian terrain or rocks and doing their final checkouts in manners that they're going to be in actual use. Back to the sampling caching system, after we get through the instrument checkouts that we're doing in this first drive with RimFact, we're going to get into the beginnings of deploying various parts of sampling caching, like the belly pan off the rover, things like that. Then we're going to do the helicopter tech demo, then come back and finish commissioning the whole sampling caching assembly line, if you will, with the internal arm to handle the sample tubes and the sealing station and all that, so that we're totally prepared to be able to capture samples and get them ready for return to Earth.
Thank you. And up next on the phone lines is John Amos from BBC London.
Hi, people. Thanks very much, and it's good to talk to you. First question really is, are we able to say that we've kind of moved from commissioning phase now into exploration? I mean, you're going to be moving now and doing stuff. And really for Katie, that clockwise route, does that take you past that particular mound that you showed us? And what's quite interesting about it is that there's a defined rock wall on that. And when you look at in the distance at the main delta formation, there seems to be an awful lot of, how can I put it, dusty slope as opposed to defined rock wall, which you could get up close to and examine those layers.
Yes, I can take that question. So to address the first part, so while the rover is still doing a lot of engineering checkouts, and we do, of course, have the helicopter mission to get started, I do think the minute the rover begins to move, we can consider ourselves explorers on the surface of Mars. And so I think very much we can say that, though we won't really begin our science exploration mission in earnest until the helicopter has finished its mission. And yes, I can confirm that the delta remnant that I showed in the image is along that southern path. And we are intrigued by these resistant outcrops because we know there is indeed rock to explore there. But, we're also intrigued by these slopes that are kind of weathering back into the delta outcrop, because while there are parts of the delta front that look like rocky slopes, what that tends to mean is that those rocks are less resistant to weathering, and often because they are finer grained, and that's very characteristic of things like shales here on Earth that you might expect to find in a delta deposit. And those very fine grained rocks that you see in a delta deposit are those rocks that we are looking to study for potential biosignatures and signs of organic carbon. And there are places along the delta, not necessarily viewable in our images just yet, that are equivalent to those slopes, but actually we can tell from the orbiter images are actual rock outcrops. And that's really what we're interested in exploring once we get to the delta. And so we're interested in checking out these different types of rocks within the delta, including these very fine-grained rocks, as well as the more resistant, likely sandstones that we're seeing in those first images of the delta remnants and the front of the delta.
Thanks.
Thank you. Up next, we have Stephen Clark from Space Flight Now.
Thank you, Stephen Clark from Spaceflight Now. I'm just curious when you expect to take out the drill and collect your first sample, will that be on the drive toward the Delta, or will you wait until you get to the Delta? And also, going forward, will you be releasing daily status reports or summaries of what's been going on with the rover, like JPL has for previous rover missions? Thank you.
I'll tackle the first part of that. And yes, in that from a science perspective, we are very interested in the rocks in and around where the rover is, as well as the rocks along the way to the Delta and at the Delta itself. So when sampling capabilities do come online, and I'll pass that to Robert to address in a moment, but we are interested in drilling the types of rocks that we have in and around the landing site, but those also extend further along the path that the rover will likely drive to the Delta. So from a sampling perspective and a science perspective, we're interested in sampling the rocks in and around where the rover is now, as well as the ones that we'll see along the way to the Delta.
Sure, thanks, Katie. And as far as getting ready engineering-wise for drilling, that's going to happen after the helicopter tech demo, when we finish all the commissioning and calibration and checkouts for the whole sampling and caching system. And using the robotic arm and the abrader and core is going to be part of that. And then to your question about the daily reports, I don't have the answer off the top of my head. I can look into that, but I will say that our raw images website is up and running, and so all the images that we take get dumped on there within 24 hours, I believe. And so anyone can jump on there and see the rover tracks showing up shortly, and all the mass cam panorama images and everything's dumping on there daily from an image basis.
And Stephen, also so you know that we do have updates that we're trying to get as quickly as possible online. You can go to @NASA Persevere on social media for updates, and you can also go to mars.nasa.gov/perseverance. Again, that is mars.nasa.gov/perseverance. And then the next person on the phone line is Leonard David from Inside Outer Space.
Hi, thanks very much. I just had a kind of a broader question about NASA has, now 3 robots on Mars. I was curious about brain drains between projects. I mean, do you have people with expertise running between the projects, or are they sequestered in their own particular mission?
I can start with this one, and then I'd like to hear Katie's thoughts as well. So I worked on the Mars Science Lab for 7 years, and then I actually worked on MSL after it landed in operations, and worked on Mars 2020 half and half. So that's anecdotally to say we have the same engineers that are flowing between missions and carrying this exceptional Mars program forward, project to project, and the same will be happening with the sample return rover. We have engineers go back and forth, scientists go back and forth between the projects and share knowledge between the projects. And I'll say with this mission, with this rover, this is the first time that we've had a system that's been designed so close to, or we started from a heritage standpoint, we started from the MSL design. So all the folks that designed and tested that and put it on Mars, they're all at JPL already working on the project or around, and so we're able to pick their brains as needed. So I'd say it's not a drain between the projects, but more a confluence that takes advantage of all those same engineers who can chip into these different missions in each of their life cycles.
And
That's
also,
great. Thanks
from a
very
science
much.
perspective, many of our science team members on the Perseverance mission also work on Curiosity, and I'm one of them. I did an MSL ops shift a week before we landed, and I actually have one coming up in a couple of weeks. And so it's not uncommon for our scientists to go back and forth between missions. And while a lot of the science attention right now is on Perseverance and its landing site, Curiosity is getting into some really exciting things. And so the science team many are going back and forth between the missions. And we've got exciting missions exciting science to do on both. And what ends up happening, which is really a great synergy, is that once you have folks who are working on two different places on Mars, as scientists, we can kind of kick our brains into thinking about, well, how does this site compare to this site? And what are we learning here at this landing site that can help us understand the geology of this other location? And so we're able to think about it in that way, which when, you've got a single place that the science team is working on, you can't do that kind of comparison. And so it's really exciting to be able to compare different places on Mars because we learn more about the geology when thinking about that comparison.
Great, thanks.
Thank you. And to our reporters again, when you're finished asking your question, please hit mute. I'm going to move on now to Leo Enright with Irish Television.
Thanks very much. And we journalists are multitasking on multiple missions as well, I can assure you. I had a question for Katie Morgan, just to clarify where these layered rocks are. Are they the prominent feature in Katmai, or are they, it seems less likely, the feature down at the very south of Big Bend? Second question, if I may, also related to the Delta remnant issue. If you do decide to go counterclockwise, would you be tempted to scoot over to Channel Islands? It would take, I guess, 10 days if you're driving and chewing gum at the same time.
Yes, thanks for that question. I can confirm that the Delta remnant that I showed in the image is indeed in the Katmai Quad, and that's something that we are certainly very interested in considering along this clockwise route. If we do end up thinking about the counterclockwise route, I think the science team will be interested in considering a diversion over to what we think very likely may be Delta remnants as well over in the Channel Islands Quad. And for folks in the line, different quads that we have in the landing area for Perseverance, we have named after national parks and preserves, and so those are the names that I'm referring to right now. And so yes, along both of those paths, we have the potential to study what could be remnants of the Delta, and that's going to factor into the science team's discussions about these routes and the scientific potential of each of the options, anticipating that we can, again, preview the Delta before actually arriving at the main deposit.
Thank you, Katie. Up next on the phone lines is David Curley with the Discovery Channel.
Thanks very much for taking the call. Some spectacular images. You guys must be very excited. I don't want to get too far ahead since you haven't even checked out the sampling system. But with the contract now being out for the retrieval spacecraft to go get those samples, it becomes more real. Can you just give me a sense of what you thought that, in 7, 8, 9, 10 years, you may actually be looking at material from the rover that you're now monitoring?
Sure, I'll start with that. This is, first I have to say, the imagery coming down, the cameras that we have on this rover, the 25 cameras and the resolution, the colors and the spectrums, it's just been amazing. We've never been able to explore Mars in this way. And then the prospect of really, in earnest, starting the sample return mission, this is one for the ages for JPL and NASA. We've been talking about this for decades, engineers and scientists around here wanting to do this. And we've also had a first with this project. As far as I know, the next rover to return the samples was Baseline, was given the green light before launch. And so all things considered, that's a huge, confidence statement in this project and what we're doing, and the institution's ability to land systems on the surface of another solar body with high confidence. So it's been incredible being on the surface for 14 days now, being able to get into a position to actually start the sample mission. And I'll let Katie talk to the excitement of the samples that we might be able to get, and the prospect that even though it seems like a long time away, it's going to pass in the blink of an eye when we'll be able to get these coming back to Earth for scientists all over the world to analyze.
Yeah, and we've been thinking on the science team about notional samples to collect in Jezero Crater for years now, and thinking about the potential there for Mars sample return and return sample science once those samples get back to Earth. But of course, that's always at a very high level because what we had to work on were only the orbiter images. So now that we're on the surface, seeing the actual rocks through the eyes of the rover, it adds a whole other level of detail and excitement about the sampling that this rover is going to do on the surface of Mars. And so, we're already starting to think about, are these rocks in and around where the landing area is? Are these rocks that we're going to want to put in our sample cache? And what would come next, heading to the Delta? And so we're actually talking about real rocks now. And that's so exciting to us in the science team because we can start to really think about the impact that these samples will have on future scientific endeavors and our understanding of these big questions we have about life beyond Earth and the evolution of planets in our solar system.
Thank you.
Thank you. We also have a social media question coming in. Anais Ed on Facebook asks, when driving, do you just lay in a course and let AI handle the details, or do you have a program that the mechanics for each wheels according to the specific typography?
Yeah, so there are a couple different ways to drive a rover, right? If you know what the terrain in front of you looks like, you can give the rover very specific instructions like we did on our first drive, right? You can say, drive so many meters forward, turn left, then drive this far, then do this thing. But you can only do that for so long, right? A few tens of meters, as long as you know what the terrain underneath you looks like and you know that it's safe to drive on. But once you get into longer distances, that's where our AI and our AutoNav comes in. So over longer distances, so we're talking like tens of meters, you don't necessarily know what the ground looks like underneath you at all times, or you don't know in that great of detail. So you will give, or what we'll do is give the rover a goal, some tens of meters away, wherever we want it to go. And then from there, that's where our AI kicks in. It'll start taking stereo pairs of images, processing those images now on our VCE instead of our main computer. And it'll identify hazards in the terrain and then decide on its next drive step, essentially, forward. As far as how it decides what's safe, it kind of like you mentioned, right? It analyzes what is going to sit under each individual wheel, and then from that determines whether or not it's going to be safe to drive over that. If a rock is too tall, we're not going there. Mark that spot bad, don't drive over it. Choose the next available option.
Thank you. And we have a reporter question, Mike Howard from American Spectator.
Thanks a lot, and thanks for doing these calls. I got a question for Robert. The Perseverance has a twin rover on Earth. I think it's called Optimism. You can use that to work out any potential issues that Perseverance comes across. Does Ingenuity have a similar twin? And for Katie, is there any scientific data to be gleaned in visiting the Sky Crane crash site?
Sure. So I'm not on the helicopter project, but to my knowledge, I don't think there's an exact duplicate of Ingenuity, but there is a test set of electronics and some other mock-ups and prototypes and stuff. And obviously, flying a helicopter in the Mars yard at JPL is a different story because of the difference in atmosphere between the two planets. But of course, that was done with the flight helicopter and other test versions in a vacuum chamber earlier at JPL. So don't hold me to that, but for sure there are significant parts of it that have a duplicate for testing. And we've used those for tests with the rover in the Mars yard and other places to get ready for this whole mission.
And in terms of the second part of your question, the entry, descent, and landing engineers would certainly probably appreciate if we drove over to the places where the EDL hardware has crashed on Mars, so they can take a look at how it interacted with the surface and where it is. But from a science perspective, we typically steer clear of places that the mission has impacted, literally and figuratively, the surface of Mars, in that we're looking now at this point for pristine parts of Mars that we have not influenced in any way. And that's particularly important for our sampling objectives and making sure that our samples really represent what Mars has to offer as opposed to what we brought with us. And so we typically steer clear of thinking about science in and around places where the EDL hardware has impacted the surface of Mars.
Thank you. And that is all the time we have for questions today. Unfortunately, we can't get to all of them, but reporters, you can call 818-354-5011, and we will get you follow-ups and continue to answer any questions that you might have. We'll also be doing that via social media. Now, for more updates on the mission, visit nasa.gov/perseverance and mars.nasa.gov/perseverance. You can also follow us on social media at NASA Persevere. And to those following Perseverance's journey, you inspire us as much as we hope this mission will continue to inspire you. Thank you for being with us on this journey of exploration. We're going to close this briefing with a video looking back at the landing that happened just 2 weeks ago, and the people around the world who joined us and supported us through this event. Thank you.
Propulsion, go. EDL phase lead, go.
We have deemed Perseverance ready to execute entry, descent, and landing on her own.
Confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second, about 120 kilometers from the surface of Mars. It will start controlling its path to the landing target. Parachute has deployed, and we are seeing significant deceleration. The heat shield has been separated. Perseverance now has radar lock on the ground. The back shell has separated. Skycam maneuver has started, about 20 meters off the surface.
Tango Delta, nominal.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.